Okay, so current dividers, I've kind of drawn two circuits there, and the first one's the very basic one to kind of illustrate the method of how you do a current divider. So if you want the current I1, then the current you're dividing is IS, and you multiply by the resistor in the opposite branch. So I1 flows through R1, so that's not the one you put in your current divider, it's this one, R2. And then you do that over R1 plus R2. That's your basic current divider. That's the rule. So then if you went on and you did I2, again it's IS that's dividing, but I2 flows through R2, so you do the one in the opposite branch, R1, over R1 plus R2. And that's a very basic current divider. Current dividers really come into their own, though, in circuits like this circuit. So in this circuit here, you would have an IS that would divide into an I1 and an I2. Then your I1 would divide into an I3 and an I4. That's really where current dividers come into their own. So this very basic that shows you the rule, that's all very well, but this is really where it starts to kind of take effect. And I think this will be the one that we'll have a look at trying to do. So we'll pop some values in here. Okay, so we'll say your supply current there is 5 amps. You've got an R1 of 20 ohms, taking you into this parallel section with a parallel section inside it. So you've got your R2, your R3, your R4. R2 is 40 ohms, R3 is 25, and R4 is 10. Okay, let's have a go at that. Okay, so when you're looking at this circuit, then the first thing you should do is to develop this kind of equivalent circuit. So in this equivalent circuit, I've taken out this parallel part and I've put in an equivalent value of RP. That equivalent value of RP I've worked out to be that 15.38 ohms. That's where that's come from. And then you can do your current divider based on that structure on this kind of equivalent circuit. So you do that for I1 and you would also do that for I2, following the same structure. So for I2 in the opposite branch it'd be RP over RP plus R4. And that would get you those first two. Now from that, what you would then do is take that your I1 comes along here, hits a junction, and then splits into your I3 and your I4. Your I3 taking you through R2 and your I4 taking you through R3. And then you'd base your next current divider on that. So when you go to do your current divider for I3, the current you're dividing is I1. That's the current before the junction, not IS. So I1. So focus out on that a wee bit. No, because it's this I1 from over here. It's this 1.97. So your current comes up here, hits that junction, divides. Then that divided current then hits that junction and divides again. So it splits once, splits twice. So when you do this second current divider, the current you're dividing instead of being IS is I1. Then the opposite branch for I3 would be the one that's got R3 in it, over R2 plus R3. So that's your method, if you keep going with that. So this wee section in red that I've drawn here is just this wee part in here. So your IS is divided, that 5 amps is divided into I1 and I2. So this is this working over here, I1 and I2, which is a pretty standard current divider in that style. Then you've zoomed in to this wee section here. And this wee section here is this circuit, which is where I3 and I4 are. This says R2 and R3. So that's R2 and R3. And then you're dividing this current. So it's I1's the current that you're dividing this time. And R2 and R3 are the resistors in this parallel part here. And that would be the structure of your current dividers there for that. Okay.